name is Bill Farner. I've been working with our team about 4 years now on Apache Aurora. It's gone through several name changes before coming to Aurora. And here we are now in the Apache incubator. We joined the incubator in November. We've been working a lot to try to foster the community. Dave's been a huge role in that. It's been going relatively well, and hopefully we can do more things like this to try to educate more people about it and get people interested in it, and hopefully more people contributing. So one of the difficult things about Aurora is trying to define what exactly it is. If you read the abstract for this talk on the meetup, you may have seen the term service scheduler, and it's pretty vague. It's kind of hard to understand what exactly that means. A lot of things could technically be described as a service scheduler. So we'll try to use a different metaphor instead to maybe explain it a little bit differently. So when you're running processes in a data center, a lot of what you do normally, if you're not using a cluster management system, you're using something like something like Puppet or Chef, and you're kind of writing these descriptions for what you want to run. And Aurora is kind of like that. You give it instructions to create tasks. So in that sense, it's kind of like a factory. Although that really only considers the scheduler. The scheduler is what's told what to run, and it creates new things over and over. So if you consider the client as well, Aurora as a whole is actually kind of like a factory. However, I've heard that's not a very popular term. So we're going to try a different metaphor instead. So one of the engineers on our team suggests that you might consider Aurora to be kind of like a templating system. So you consider your tasks sort of like a rubber stamp. So these are the descriptions that you give to Aurora, and we'll talk about the configuration language in a little bit. But you're basically writing a recipe for creating tasks. So that's kind of like your rubber stamp. You want to create this thing over and over. And in that model, Aurora is kind of like the holder for all of these stamps. You give it these things, you give it some instruction of how to actually use them, when to use them, and it just kind of goes on its own at that point, and autonomously is using the stamp over and over throughout the data center, creating things with these recipes that you've given. And it turns out this model works pretty well for a lot of use cases, and it really shines in big clusters. So when you have really large installations of machines, this can save a ton of effort for humans, both the operators and the developers, so that you can use a relatively small engineering team to manage big fleets of machines and also manage large services that are spread across many, even thousands of machines. On the other end of that, it's kind of hard to say exactly how small you can go with something like Mesos and Aurora. To give an idea, there's sort of a fixed overhead for running one of these clusters. If you've used something like Zookeeper before, you may be a little bit familiar with some of the nuances there and some of the reasons that you have certain numbers of machines. For even reasonably reliable clusters, we recommend at least 3 machines to serve as like the masters. So you could put your Zookeeper there, your Mesos master there, and the Aurora scheduler there. And actually, before I go much further, so I can kind of have an idea of how deep to dive into different subjects, how many of you have never used Mesos before? Okay, just a couple. And how many of you have never used Aurora before? Awesome. So this should give you an idea of kind of what the lower bound looks like. Not everybody has a huge data center. Not everybody needs a huge data center. But basically, once you go a little bit past that 3 machine, that fixed overhead starts to make a lot of sense so that you can very easily grow your cluster. You can lose machines. You can lose different parts of your installation without having to worry too much about it and without having to rethink everything every time you add new machines or lose machines. Another way that this really works nicely for is for redundancy. So redundancy is great because it's a very easy way to add both performance and tolerance to failure. So in that sense, another way to think of Aurora is kind of like the software RAID controller for the data center. So it's given instructions for how many of a certain thing you want. It's going to adapt to loss of a particular component of the system. And in that metaphor, Mesos would kind of be the disk controller. So it's doing the interfacing with the raw hardware. It's letting the software controller know when certain things are present or absent, and the RAID controller is kind of figuring out what to do with those resources. So with this kind of system, it's really important to take certain design considerations along with you. And one of those is to Travellight. So to think of these processes that are running in this system as stateless as possible. And this is kind of a good thing because it actually forces these design choices. They can be a little bit uncomfortable, especially as you're moving into something like this, which we've noticed a lot as we've moved a lot of Twitter infrastructure onto Aurora. But it actually has a lot of nice properties after you're already into it. Things can grow very rapidly. They can shrink very rapidly. We can start to talk about doing things like dynamic scaling, which we don't do yet, but we would actually like to consider those types of things. But stateless processes are really key. Also, not really being concerned with where certain things are running. So, having things like fixed sets of hosts floating around in your configuration files are actually really binding once you're in a large installation, where a loss of a machine means you actually have to go and adapt a whole bunch of configuration files. I'm sure a lot of you, if you've dealt with large clusters, have had to already figure out solutions to that. And I know there are a lot of approaches, but this is another design consideration that has to be practiced in order to make this kind of thing work. As for the implementation, there's a lot of layers in the system, as there are with most distributed systems. If you're familiar with Mesos, you know that there's a master and a slave component. The master is kind of the resource accounting point, or centralized point for the resource accounting. The slave is doing the actual execution. It's announcing itself to the master, and the master is delegating these resource offers out to the scheduler. So Aurora, if you're not familiar with the Mesos terminology, is a framework. So it implements the scheduler part of the framework and the executor side. And those kind of have their separate responsibilities. So I like to think of this as layers because, as it turns out, we actually implemented some of these things almost in a clean room fashion, where the scheduler existed and we implemented the executor as decoupled of a way as we could. And this is really nice because Aurora is not really opinionated about, or Aurora scheduler anyway, is not opinionated about what type of executor you use. So you could imagine actually using it with different executors if you wanted to use an executor that runs virtual machines or anything like that. You could do that relatively easily. The code as it stands today would have a little bit of issue with that, but it doesn't take much to get there. There's also additional layers. So as we'll see in the configuration in a little bit, we have a DSL. So that DSL is actually its own independent project created by Brian Wickman, who's over here. And that thing has nothing to do with anything that is Mesos and Aurora. So it's kind of nice. We've ended up with all these different little pieces that have very little coupling but high cohesion, which, as in computer science, those are good properties. And to go a little bit more into some specifics, but to not dwell too much on the details, you can think of the scheduler in Aurora as a group of state machines. So these are those stamps with a replicated storage system. A little bit more detail there. If you've used Mesos, you may have come across the replicated log. So that's what we use for our storage system currently. And the executor is more or less a rather complicated bash execution engine. It does a lot more than that, but I mean, when you first play around with Aurora, you might be wondering why you're not just writing bash, why you're writing these sequential processes. But as you'll see if you get further along, there's a lot of power that comes with that, and there's a lot of effort that you save by using these kind of constructs. The executor also does health checking, so we like to do additional liveness checking for processes that run in Aurora. This is really helpful in production, so we can notice kind of at the application level when things are sick. This has actually helped us a lot when things stall for unforeseen reasons, where the exit of a process might actually not be the only indicator that you want to use to decide that you want to restart something. There's a lot more details than that under the hood, and unfortunately a lot of those are not really user-facing, but basically the reason that we've been developing Aurora for 4 years is not because we've built this huge, rich feature set. It's actually because we've been kind of pounding on it constantly in a production setting to work out all the kinks, to make it extremely resistant to failure, and make it adapt to failure as much as we can. And as I mentioned, a huge amount of Twitter infrastructure actually runs on Aurora, so we've got a huge commitment there. But if you ever dig into the code and wonder, like, why are there 40,000 lines of code dedicated to this, it's because it's gone through a lot of battle testing, and there's a lot of different features that, that make it possible to actually use it in a large-scale production setting. One of those features is a lot of the things for operability. So the scheduler, for example, has support for things like machine draining. So we like to try to gracefully kill things when we need to, for example, do kernel upgrades on machines or switch upgrades. And for the most part, the system actually doesn't really care about these. So I mentioned that, you know, machine failure, rack failure is not really a big deal. However, we do like to do it gracefully when we can. So Aurora gives some additional features above Mesos so that we can kind of be smart about scheduling, so that we can optimistically restart things. And a lot of these result in a lot of code and a lot of time spent. So this is a quick glimpse at what an Aurora configuration looks like. So there's kind of two distinct things going on here. There's a description of the resources, which if you've used Mesos before, that's probably a little bit familiar to you. That's basically what we're going to match our resource offers against. So the master is constantly sending the scheduler these resource offers. So this is what we're going to use to decide if something can actually fit in the shape of offer that was given to us. And then is kind of the meat of it, what you actually want to do with your resources. So there's, I mentioned that you might be wondering why you wouldn't just use bash, and sometimes the line is a little bit blurry. Like, you could just actually use a really quick bash pipeline for this, but if you wanted to do more complex things like looping, or there's things like finalization, where this type of stuff actually starts to really make sense. So in this particular configuration, we're running a sequential task, so that means we want to run each of these processes after the previous one completes. And all we're doing is downloading, unzipping, and executing a zip file and a shell script that's contained within it. So that's kind of the stamp. So now the instruction for actually how and when to use that stamp. So this is a job description. So these are, this is one of the higher level constructs that is provided by Aurora. So Mesos operates on the concept of tasks, which is a single execution of a unit of work. Aurora introduces instances and jobs. So an instance is kind of a multi-generational execution of a task. So that could be a process being executed over and over as it fails, as it exits, as other things fail. And then the job is a big collection of instances. So that would be your service. And in this case, we've used the name service, which means basically run my thing forever. Doesn't matter how or why it fails. Just try as hard as you can to always keep it up. And you can see there's an instance count there, so that's how many we want to try to run at any given time. And of course, we don't know if we can satisfy that. There's a lot of, or there's several other constraints that define whether the cluster actually has enough capacity to run that. But that's basically what we're trying to strive for. So now I have a quick demo. I would not advise running this on a machine that looks like that, though. And basically all I'm going to do, I'm basically just going to run through the tutorial. So I'll show you at the end the website address for Apache Aurora. And really that's all I'm going to be running through. But just for a basic 3-command get up and go, you can clone seeding the directory and vagrant up, and you'll have an Aurora cluster running. So I'm in the repository on master. I've already done vagrant up, so I'll do status. And there are several, basically I have all the key components running here, so it's a little mini cluster. There's a dev tools thing that's really just used for building, because we try to build in the target environment. I'm on OS 10. There's a single zookeeper instance. There's a Mesos master. We have 2 slaves and our scheduler, all in independent machines, which is kind of convenient because then we can deal with them independently. We can tear them down independently with relative ease. So the tutorial describes several steps that you need to do. So basically, there's a Python script, which is the script that we want to run. So this is kind of our mock application. So what I'm going to do is just create a file. It instructs me to create hello-world.py. This is probably invisible to anybody in the back. So I'm going to create this file. So just going to blindly paste it in there because that's what we do in tutorials. And now for the actual configuration. So there's a lot of things going on here. I don't know if I'll spend much time going into that, but it's basically kind of a regurgitation of what I just went through. Okay, so I should have my two files. So our client happens to be built and stored on the scheduler machine. So I'm going to SSH into that, or maybe not. OK. And finally, so there's a little bit more prose in here to kind of explaining to you how the plumbing all works. I'm going to gloss over that right now. This is kind of just some configuration for how the client actually knows what to talk to. And if you play around with the client, we try to make it as self-documenting as we can. So it will show you kind of the basic commands. And it has relatively good help, but we're always accepting patches. So finally, we can actually create our job. So what I'm doing here is referencing the name of the job. So everything operates, for the most part, at least when it makes sense, on the concept of what we call a job key. So this is cluster/role/environment/job. So these are just kind of namespaces that you can use. In this case, www.data happens to be just a user that's available on the machine. So we actually do execute processes as the target user. And the client tells me that my job should be running. So I can go to the scheduler. So this is my user. So in a normal cluster with multiple users, you'd see a big collection of rows here for the different groups. And then we can actually go and look at the task and find that it's pending. So this usually means that we're not getting resource offers. This is what I was dreading. All right, let me try to do surgery. Yeah, usually, as Ben advises, if anything's going wrong, you restart the master.
It's a very safe operation.
Oh. So now we get into a delay where we start to see some of Aurora's resiliency features come in, where it's backing off on this task if it has offers because it's failed to schedule it. OK, so we have offers. OK, great. So our task failed. That's fantastic. And however, as you'll see in the tutorial, that's actually intended. So this is kind of to teach you how to actually debug something should it go wrong. So this is where we get into the executor. So here we've hopped over to the individual machine. And there are a couple of things going on here, but basically we try to expose as much information as possible, both for our own debugging, but also so that people can figure out what's going on or going wrong if they want to. So you can't scroll to the bottom of the page totally, but you can see that our fake fetch package process succeeded, but hello world failed. So we can look at the output from that process and figure out what went wrong. Or not. Well, nonetheless, if you run the tutorial, you'll find that the problem was actually an intentional syntax error in the script. Not that one. So if anybody knows Python, you might recognize that we use the xrang function when we meant xrange. So we can recreate that job. Okay, so we should be running again. Okay. So for some reason the output doesn't show, but we're successfully running at this point, and that's kind of the point of the exercise. You can imagine that you were thrilled to see "Hello World" printed several times. So as you can see, basic Hello World is relatively simple to get going. There are a bunch of features that are not really complete yet, so they might feel a little bit like the staircase where it looks good, but there's parts of it that aren't really usable yet. So this is where the accepting patches part comes into play. And a little bit about those. So service discovery, this is something that, as I mentioned, host lists are pretty insidious and difficult to manage, especially as your clusters grow. So there's a lot of solutions out there for service discovery. We have our own at Twitter. We have something that we would like to start pushing for in Aurora. But as it stands today, you might get to the point where you're like, all right, I'm going to start up my server and then not have any clue how to actually have it talk to anything. So this is kind of the missing link there. We need to give you a story for how to talk to other things, how to discover the services that we've launched in Aurora. Authentication is another huge one. So I mentioned that the UI shows users, the job keys are all based on users. However, in the open source project, it's kind of all just on the honor system. And if you notice in the tutorial, you'll see there's a big thing saying authentication mechanism unauthenticated or unsecure or something like that. So this is another thing where we have our solution internally, but it wasn't really what we wanted to open source. So we'd love to get input or get code, ideally, for an actual legit authentication system in the project. But again, we do kind of have an idea there and have a plan to kind of fill in that gap. And the obligatory contact us slide. So you can reach our website at aurora.apache.org. Again, we're in the incubator right now. We're hoping for a first release within the next few weeks. And then if all goes well, we'll be graduated not too long after that. And then our Twitter account is Apache Aurora. And we have a project hashtag Aurora. And that also happens to be our IRC channel, which we are actually pretty active in. So if you're using the tutorial or trying to get your installation working, don't hesitate to go in there. We're on Freenode. Anytime business hours, we should be pretty active. So that's it for my presentation. I'm happy to answer questions now or later. But if you have any now, I can definitely address them. The question was kind of some more details about our authentication system, how we actually wired that in. So it is kind of a plugin. So if you look at the code, there's basically an interface in the scheduler that is used to validate incoming requests. And then It's a little bit easier to wire in Python because we don't have to have the type safety. So we have, we basically have some sort of interfaces and hooks that we can kind of inject our code into to kind of provide the credentials on the client side. But basically, it wasn't industry standard, so it really wasn't worth putting into the open source project. Right, so the question is, do we have anything to manage dependencies between service? And I assume you mean kind of like actual proper ordering of starting things? Yeah, so we don't have that today. It's a very interesting thing we haven't really gotten into. We try to provide as many primitives as we can without being too involved with kind of how the sausage is made, even at Twitter, just because it's a lot easier if we don't get ourselves too involved there. But we've definitely talked about that, at least within the scope of a configuration file. We've talked about kind of using that to construct a service diagram, which would also be hugely informative at a big company. But yeah, kind of like gated startup would actually be a really cool feature. And I know it's been asked for things like load testing, so that you can kind of bring up a multi-tier service without having to coordinate manually. That would be really awesome. Yes?
What about rolling restarts?
Thank you for asking. So the question was, what about rolling restarts? So our client does that. Basically, so this is another cool thing about going back to the layers. I was supposed to talk about it then. So updates are something that we do provide. We kind of give you the controls for the velocity and health checking and all of that when that's going on. And the cool thing about updates is actually none of the rest of the system knows about updates or knows that they even exist. But yeah, from the client's perspective, you can do them. The way that they're coordinated right now is fully from the client, so unfortunately you kind of have to be present at the terminal, at least if you're using our sanctioned client that we provide, but there's nothing stopping you from basically doing that via the API. So the question is, when we do an upgrade, is it a new job to kind of replace the old, or is it sort of in place within the scope of the existing job? I think it's somewhere kind of in between. So we don't do like in place within the scope of the task. So we're not communicating like kind of outside the realm of Mesos. Really all we're doing is killing a task and creating a new task. We actually used to do it in a little bit more of a complicated way, but we found it actually really convenient if none of the rest of the system knew about it. And it seemed to fit pretty well into the task lifecycle to do it that way. Right, so the question is about both jobs and cron jobs existing and whether we use Chronos. So we do not use Chronos. So Aurora has sort of support. I guess this probably should have gone into the half-baked features. So we have cron support internally to Twitter. Unfortunately, we were using a library that was not compatible with the Apache license. So we had to re-implement all of that stuff. So the feature is kind of there. You can kind of see remnants of it, but it doesn't actually do anything. We actually basically are in review right now to get that feature back there fully. But yeah, it's not using Chronos currently. So the question is, have we seen performance gains by co-locating processes that are different versus just running independent or similar processes on the same machines? We haven't done a whole lot of performance study on that. I know we have basically a team that is focused on the resource isolation aspect, so they are actually doing what we call interference studies. That's more at the Mesos level, so I've basically delegated or been happily ignorant to all of that stuff. But I mean, I do know that based on our usage, there haven't been performance impacts great enough for us to back off. So we are, based on our installation, we're not really running single tasks on machines. There are many tasks per machine. So the question is, does Aurora do any kind of rebalancing? So kind of like online bin packing. We have not invested in that currently, mostly because basically it's highly complicated. It does interrupt things more than we would like to. But I would say mostly we just haven't really had the demand to do it. But it's probably something that we'll be looking into as we try to actually push the utilization higher and higher, especially when we get into situations where there are critical things that we can't schedule because of bin packing inefficiency. Yeah, so the question is, how do we do health checks? So basically, this is one part of the demo I didn't get to, but so we allocate ports. So in the Mesos monikers, we use ports as a resource. So we don't do any kind of smart network isolation currently. We're waiting on those features from Mesos before we actually try to do that. So we basically allocate ports, so you can allocate named ports, and this actually can feed into the service discovery and registration aspect. But basically, when you request a port named health, that's kind of subscribing yourself for health checks. So that's all over HTTP. There's kind of a well-known endpoint that we hit and a response that we expect. Yes, yeah, thank you for asking that. So the question is there any sense of location, something so that you don't schedule things on the same rack per se? So Aurora provides a mechanism so that you can do constraint matching. So constraints can be either values. So an example there would be like architecture x86-64 if you wanted to be on a particular type of CPU. And we can also do limit matching. And the way that works is you can specify like host being limit 1. And that's basically saying schedule at most one of my tasks within my job on a particular host. And that's all based on the attribute system. So that if you're familiar with the Mesos constructs on the slave side, you can provide basically tags that you give to machines or slaves. So you can provide, like, for example, host, rack, PDU, row, and you can kind of at the task description level, or job description level rather, say like how diverse or how much affinity you want to go up to within those different dimensions. Okay, so the question is basically how do we digest the logs that are produced by Mesos? And just to be clear, is that from like the slaves or from the tasks that we're running, or both? Okay, so on the slave, we don't really do much. We just basically, a typical log rotate setup. So we're not doing any centralized collection of that currently. That's worked relatively well. As far as applications, so again, we like things to be as stateless as possible. So that includes logs. So we will delete logs or along with the sandbox. This does surprise people relatively often. So we heavily encourage people to leverage other solutions. We have several within Twitter, and I don't think there's a shortage. Scribe, I know, is a popular one that people use elsewhere, but that is kind of a game that we don't want to get into, just because we want to be really good at the cluster management and scheduling and execution, and not so much get into storage and other kind of external systems. So the question is basically, could Aurora be used on different backends? Yes, I think it would take some engineering effort, just because some of the constructs do permeate relatively deep, although we've tried to be careful of that. But I imagine things like just managing the offer flow does actually maybe not translate well into other similar systems. But yeah, I mean, yes and no. I wouldn't be against it being moved to different backends, but it might be complex.